Hello ATS 315 students, Dr. Shragi here, and we are ready to move on to assignment 4 in the class, which is going to be about getting some input from the user and using this information then to, you're going to ask the user for things like temperature and dew point, and you're going to use that information to do calculations, common meteorological calculations, compute things like relative humidity and vapor pressure and wind chill and stuff like that. And the way you're going to get input from the user is you're going to use another function, just like the printf function was in C. You're going to be using a new function to you called the Scanf function, which is also part of standard input and output. Hopefully by now you have read the corresponding chapter in the textbook. If not, please do. It's going to be very hard to make progress in this class if you don't keep up in the readings. Alright, so typically the way the process is going to work when you're going to be getting input from the user is you're going to use a printf statement to prompt the user. You're going to use a printf statement to say something like, please enter a temperature in Fahrenheit, or please enter a wind speed in knots. Notice you want to make sure you tell the user what the information you want is, including what units. Otherwise the user will be confused as to how to correctly answer the question. And then you're going to use this scanf function to actually read the input that the user gives you. The function that we're going to do this with is scanf. Scanf is with a lowercase s. I don't know why PowerPoint rendered it with a capital S up there, but it is a lowercase f. It is the scan function. Scan is a word that in computers they typically use to mean something like find input or something like that. It's a function in this case. Scanf is a function. It just like printf was a function. Scanf is a function that accepts input from a keyboard and puts that input into a variable. So you'll have declared, say, a floating point variable called something like tempf for Fahrenheit temperature, and then you'll prompt the user with a printf statement, please enter a temperature in Fahrenheit, and then you use the scanf function to read the input from the keyboard and put it into the tempf variable. And we'll see how that's done. Here's a little piece of code. Again, I've only given you just the little main block of the program here. This could be a piece of a code, though, that with pound includes and stuff like that up above it. So here's my little main block of code here. I've got a floating point variable that I foolishly just called temp. I should have called it tempf or something like that. And then I'm prompting the user to enter a temperature, and I didn't tell them to enter it in Fahrenheit or anything like that. I probably should have. And then I'm using this scanf function here. Scanf is a function. It has arguments. Pieces of information that it needs in order to work. In this case, it has two arguments that it's going to need. The first argument contains the format specifier of what you're trying to read. In this case, because temperature is going to be a floating point number, our first argument is %f, because we need this information that's coming in to be in a floating point format. If you want your temperature, let's just say it was 1 degree outside, you don't want them typing ONE for 1 degree, right? It's going to be a floating point number. Now, admittedly, the user's probably going to just type the number 1, but that's okay. I mean, the computer will understand that they mean 1.0 degrees. Notice that the type has to match here. So we're reading in a %f format. That's our format specifier. So clearly the variable that we're reading into is going to have to be a floating point number. Then there has to be an ampersand in front of the variable's name when you are reading it in with scanf. This is because strictly speaking, what you need here is not the floating point variable itself. You need what is called the pointer or the address of the variable. But on a different day, we're going to talk about why that is. For now, let's just say when you use a scanf function, you have to have an ampersand in front of the variable's name. So you're going to be reading from the scanf says you're going to be reading from the keyboard a floating point number, and you're going to be putting it into temp. I guess in this case it was temp, but I thought it was tempf. It's temp. Okay, that's what the ampersand is telling us here. It means we're going to be putting it into tempf, or temp in this case here. This is not a very difficult thing to do, and we're going to do some examples real quick. Well, I'm going to bust out of here. We'll show you some from the keyboard here. But I wanted to real quick just sort of show you what you're going to actually do in your assignment is you are going to prompt the user to enter whatever it says on the last page of this chapter in your textbook for assignment 4. I think you asked the user for temperature and dew point and pressure and wind speed and wind direction, I believe. And from that you're going to be computing things like the vapor pressure, the saturation vapor pressure, the relative humidity, the potential temperature, wind chill temperature, and zonal meridional winds. Now, you need to be very explicit when you are asking the user make sure you know what units you're getting the answer in. You know, tell the user to enter the wind speed in knots or meters per second or whatever you want, but that's what you're going to be asking for. And then when you get to doing these calculations actually in your little program, make sure that you pay very close attention in that appendix to the textbook about common meteorological calculations. What should the units be? You might need to do some conversions. And what are the units of the result of those equations? Again, you might have to do some conversions. All right. Now, what I'm going to do here is I'm going to break out and I'm going to show you some examples of how this is going to work. Okay, we're back, and I just wanted to show you real quick some examples of how to work with Scanf, and then we're moving on to the second part of this lecture here. I'm over here in my student account on Chesapeake, and I have started working on a program called sample.c again. So far I just have that basic stuff that every program has to have. And let's just say I wanted to, I'm going to prompt the user to enter a temperature in Fahrenheit, and we'll convert it to Celsius. Okay, that would be a simple little program that we might want. So like I'm going to have a floating point variable. And just to mix it up a little bit, I'm going to call it TF for temperature in Fahrenheit and TC for temperature in Celsius. And I'm just going to use the printf function to say, printf, please enter temperature in Fahrenheit. Okay, we're getting to be pretty good at working with those printf statements. And then we're going to use this new scanf statement. We're going to be scanning in a floating point number, so our format specifier has to be %f. And then we're scanning into that from the keyboard ampersand TF. It's all case sensitive. I had some mistakes there where I made the big T first. That doesn't work. The variable names are case sensitive. They do have to have that ampersand in front of it with scanf. Again, on a different day we'll explain exactly why that has to be. And then let's just say we'll do some calculations like TC equals TF minus 32.0 times 5/9. And then we can just print f, %f, I'm going to print out like this temperature Fahrenheit is this temperature Celsius. So %f Fahrenheit is %f Celsius /n. TF, TC. Alright, so the first, the TF will go into this format specifier and the TC will go into that one. Let's see if this works. GCC sample.c minus LM. Oh, got an error there. TF is undeclared. Oh, sure enough, look at that. I used TF as a lowercase. It should have been uppercase. It's not T little f, it's T big F. After I just told you that they have to be case sensitive. Alright, I'm back out. I'm going to compile again. This time I didn't get any errors. And please enter a temperature in Fahrenheit. How about 32? 32F is 0C. Now it's terribly formatted on here. I should have, used a fancier specifier that included how many digits I want and so on. Let's run the program again just to prove to ourselves it works. How about 50 Fahrenheit is 10 degrees Celsius, so let's check that. 50 Fahrenheit is 10 degrees Celsius. So see how it works? Okay, so, I mean, this business of scanf is not so tricky. Just the main thing is remembering you tell it the format specifier. You don't, in general, want to tell it something like %4.1f, because then it'll only accept the answer if it's 4 digits wide with 1 to the right of the decimal place. You just want to be generic about it. %f, it's a floating point number. If you're asking the user to enter an integer, like how many days was it sunny, that's an integer, then you would use %d for your format or whatever. And then remembering that there has to be this ampersand. That's certainly very common. Hey, let's actually demonstrate what happens if that goes wrong. Let's say you forgot the ampersand. That is an educational error. Let's see what happens here. I took out the ampersand. I'm going to compile this. Oh, first off, it issues a warning. Warnings are different from errors. Errors mean I did not, GCC did not make a new a.out file. Warning means I'm going to trust you on this, but you don't seem to know what you're doing. In this case, it's saying format %f expects an argument of type float, but is getting a type double. Though that's a tricky. The message doesn't really help me. But notice if I try to run this thing, enter a temperature in Fahrenheit, 32 I typed in, and look what it did. I entered a temperature of 32 Fahrenheit and I got 0 Fahrenheit is negative 9. And the calculation is right, but this isn't what the number I entered. Let me try that again. Let's say I entered 50 Fahrenheit. 50 Fahrenheit is my answer, my input here, but notice I'm getting again 0. Something's not right here. Testing our program proved that this didn't work, but if I put that ampersand back, it will be just fine. Okay, the second half of today's lecture is going to be about commenting your code so that programs look better and are easier for me to grade and so on. So let me just break this here and then I will give you the second half of the lecture. Okay, welcome back. On the last assignment, you might remember right towards the end of the lecture I told you about that we want our programs to have comments, documentation in them. These are like little notes that you're going to put in your program that help me understand what you're doing, help you understand what you're doing, and so on. They have a number of different tools. This is part of the broader idea of making your programs not ugly and not impossible for me to sort through what you're doing. What does a beautiful C program have? Well, for one thing, they will have nice indenting. Now, we haven't yet done anything like loops and so on where indenting is part of the strategy as to how they work, but you want your program to be, it's going to look like an outline when you're making a big complicated program. We'll get there with time. Your programs also should have plenty of white space. When there's like one part of your program that's doing one thing, feel free to put a few blank lines between that and the next part of your program. You're not killing trees, we're not printing these programs, we're not doing anything like that. There's no reason not to have plenty of white space in your programs. But the tricky thing, the one that's important, is making sure your programs have these comments or documentation. So like I said here, you need to make sure your program has nice indenting. Now so far, everything that we've done has been outside of a loop or anything like that, where there hasn't been reasons to indent in further. So right now, everything should be at most like one indentation in. Typically that is what we do, is we use one tab in for like the parts of the main program. And again, there's no harm whatsoever in having white space between the different parts of the program. I mean, there's no reason why you wouldn't have that. Comments are the one that's a little bit tricky for people to know what to do. Comments are like little post-it notes that you're leaving in your program. They're going to help you know what different parts of the program are doing, and they're going to help me figure out what's wrong with your program when something is wrong. They're going to help me grade your program and so on. Comments themselves don't do anything. They are parts of the program that don't execute. But they help you understand what's going on. They help other people understand. I mean, documenting programs is a big part of what a professional programmer does, because they're going to be sharing their code with other people. The symbols that you're going to use for a comment are /* and */. They kind of remind me of those HTML tags that we used in earlier this semester. /* and */ are like the beginning and end of a comment. Everything in between /* and */, the compiler is going to ignore. Those are going to be notes that are there for you. Now, typically, one of the main things that we do with comments is to create what's called a comment block at the top of the program. At the top of the program, you're going to actually be telling me things like who wrote this program, what the program does, what known bugs there are in the program, what you did special in your program to impress me, and so on. So like, here's an example. If I had a little stupid program right here like this, and I didn't include like the pound include statements and so on, but I just had a little comment block at the top, see the little /* and the */, that means everything in between there is just a comment. The compiler is going to ignore that stuff. And in there I said things like what the name of my program is, who wrote it, what bugs there are, what you've added to the program. Any information you think I should have, that's a great place to have it up there. That's a common use of comments. It's also commonly used to put comments in your program to describe what each block of your code is going to do. You don't need to write a comment about every line of your program. That would be not helpful. But like, maybe typically, maybe there's a group of 3 or 4 lines of code that are doing some calculation for you. Okay, a little block of comments above there that explains these next 5 lines are computing the saturation vapor pressure in grams per kilogram, given the temperature in Fahrenheit and the dew point in Fahrenheit. That would be useful information to have. A little block of information, or this doesn't seem to work and I haven't found the bug. That would be a useful comment to have. So like, for example, here in this little piece of code I gave you here, I'm declaring some variables, and then notice I'm actually mentioning there in a comment, prompt the user for input and then scan in the temperature. And then I actually do those things. Okay, again, don't go nuts, but you do have to have a fair number of comments in your program, excuse me, to get full credit. Another really handy thing to do with comments is using comments to temporarily remove code you might want to put back again. I mean, like for example, in this piece of code I have right here, maybe for some reason I don't want that line printf anymore, but I might want it back. If I delete it, it's gone. But if I just put comments around it, the compiler will ignore it. It won't be doing anything with that code. But if I ever want it back, I can just take the comments out, the right word is uncomment that, and then that piece of code is back. Very common thing to do. There is a second way to make comments in C. Instead of /* and */, another strategy is //. // is another way to make a comment where from there to the end of the line, that the rest of that is all a comment. So like, for example, you might just have a comment in there that's just // and then some notes or something. Or like, for example, often we'll do something like put some information, like in this case I have pi equals 3.0, and then I wrote // bad approximation. In other words, you know, like I'm putting a little note there that tells me something about that line right there. I mean, that's kind of a little handy. You can't think of it as like a little post-it note you just stuck on that line of the program or something like that. Now, from now on, your programs have to have lots of comments. Okay, you don't have to comment every line or something like that, but you do have to be developing the kind of habits that an employer is going to want to see. Anybody who's part of a team running programs, you know, doing research or whatever, they're going to need to have enough comments in there that other people can look at your program and figure out what it's doing. You should look through your textbook to see some suggestions about appropriate ways to comment your code. Okay, I'm going to bust out one more time here into Chesapeake, and we're going to just put some comments and some code so you can understand what's going on. Okay, so I'm back here on Chesapeake, and I'm just going to use VI to open up that sample.c program. And this program is kind of primitive in terms of how, I mean, there's no comments. All I did is I put one blank line between every line of the code. This doesn't really help me understand what the program is doing. I mean, for example, please enter a temperature in Fahrenheit and then scanning it. Well, those two kind of go together. I'm prompting the user for information and then I'm getting the information. Then I'm doing the calculation and then I'm printing the output. Maybe I could add a comment here that is output the results to the screen. That would be a fine kind of comment here. Another kind of comment maybe would be to see, like here I'll add a little double slash type comment that says F means Fahrenheit. I'm just putting a little note here to remind myself what Fahrenheit. How come I can't spell Fahrenheit right now? Fahrenheit, let's just say that. C means Celsius. There we go. Alright, so I just put a little comment there that helps me know why do I call these variables TF and TC. And so, you know, just some little comments like that will just make the program a little easier to understand. And like I said, these comment, the compiler won't even see them. It'll just ignore them here. Okay, these don't hurt anything. Notice I have all this nice indenting where everything's just one tab in. Later we'll have different habits about that, and we'll be bringing things, you know, indenting to different levels, but we aren't there yet. Yeah, I think that's pretty good. And also, if, like, let's say I just didn't want, maybe I wanted to remove this line of code. I don't know if this is working, and I don't want it to be what stops the program from working. I could put comments around it, and then that line is no longer being seen by the compiler, but it's also still there if I ever need it back for some reason. I'll put it back right now. See, oh, the line is back. I didn't have to retype it because I had commented out. In case it isn't clear, comments can span multiple lines. Like I could comment out this whole part of the program right here, so now everything across this region here is all commented out. That would work just fine. Trying to think if there's anything else I should tell you about comments. Yeah, they're just a good habit to get into with regard to keeping your program tidy and so on. Let me go ahead and close this up. And I'm going to look, I always make these notes for myself, assignment4.text. What do I, make sure I told you everything I need to know. Okay, in assignment 4, you're going to need to make an assumption about the current pressure. The problem in assignment 4 in the textbook doesn't actually tell you to prompt the user for a pressure. But some of the calculations that you're going to be doing require the pressure. So either you need to make an assumption about the pressure, like set pressure in millibars to 1,000, and then just in a comment tell me that's what you did. I decided to assume, or you can go ahead and ask the user to enter a pressure. That would be a lovely way to address that problem too. Be very careful when you're working with that equation for wind chill temperature that's in the book. It's given in Celsius. I believe that the result of that equation is a wind chill in Celsius, and I think the problem in the book, is actually asking you to then convert that to Fahrenheit. So you're going to compute, let's just say, W chill C using that equation, and then compute W chill F equals, and then a whole, something based on W chill C. Be careful about that. In that equation for wind chill, there's a 2, but it's probably better thought of as 2.0 since it's a floating point number. Notice I'm not telling you in the problem in the book what units to use for your computation of zonal and meridional wind. Your calculation will result in a zonal and a meridional wind that has the same units of whatever you gave, whatever the user used when they entered the wind speed when you input the wind speed. So, okay, I think that gets you all the information that you need. Good luck with assignment 4. Please let me know if you have any questions.